Okay, so in this video I'm going to be going over the Chapter 6 test review. The first two problems are asking me to verify, so these ones are making one side of the equation match up to the other. And I can use my identities, which is attached on the back page. I always want to choose the side that looks more complicated to work with because it'll give me more to work with. Number one, the left side is more complicated because of the fraction. I'm going to start off by rewriting these in terms of sine and cosine. If I'm absolutely stuck for what to do, you always want to just try and rewrite in terms of sine and cosine. Then I have two fractions being added on the numerator. I want to make it so I can add these together. This one's going to get multiplied by cosine alpha over cosine alpha, and this bottom one's going to get multiplied by sine alpha over sine alpha. So in my next step, I'm going to have cosine alpha over sine alpha cosine alpha plus sine alpha over sine alpha cosine alpha, all over, I did not give us enough room, sine alpha plus cosine alpha, and this should equal cotangent alpha plus tangent alpha. Then what I want to do is I want to combine my two fractions on the numerator. So I'm going to have cosine alpha plus sine alpha all over sine alpha cosine alpha over sine alpha plus cosine alpha. And this should equal cotangent alpha plus tangent alpha. Then I'm going to continue on a sticky note. Okay, so what I have is I want to write my reciprocal and multiply by that. So I have cosine alpha plus sine alpha over sine alpha cosine alpha. My reciprocal is 1 over sine alpha plus cosine alpha. And this equals the cotangent plus tangent. Then the numerator here and the denominator here will cancel out, which just leaves me with 1 over sine alpha cosine alpha equals cotangent alpha plus tangent alpha. Then I'm going to replace this one with sine squared plus cosine squared. I am going to split this into two separate fractions. Then on this first fraction, I have a sign on the numerator and denominator, so that's going to leave me with sine over cosine. On my second fraction, I have a cosine on the top and bottom. That leaves me with cosine over sine. Then I can keep going. This one will turn into tangent, and the second one will turn into cotangent. And both sides match because addition is commutative, order doesn't matter. So this is all of this work is my final answer here. I think the one on the test is a lot shorter. If it doesn't fit all on your sheet though, you can always attach another sheet of paper. Or you'll have this identity page. If you number it, you can also put it on here because it's got a whole blank side. Okay. So number 2, again, verifying my identity. This one, I have a 2x, which is a double angle. I always want to try and get rid of my double angles, but on this one, I'm actually going to work with the side that's squared, because that's going to, if I actually multiply that out, it's going to make it more complicated. So multiplying that out is going to give me sine squared plus sine times cosine plus sine times cosine plus cosine squared. And this should equal 1 plus 2 sine of 2x. Then I want to combine like terms. So I'm going to have that sine squared plus cosine squared. I just like writing all my squareds first. And then plus 2 sine x cosine x. And this will equal 1 plus sine of 2 of x. Also on the test, if you're not writing both sides of the equation for every step, I will take off half a point. And if you skip any steps, I will take off the full point. So then here, I can replace sine squared plus cosine squared with 1. And 2 sine x cosine x, if I look, is my double angle formula for sine of 2 theta. So I can replace that also with sine of 2 theta. Or in this case, 2x. Which is exactly what I was looking for on number 2. So I am done here. Moving on to number 3. It wants me to solve tangent squared plus tangent equals 0 on the interval of 0 to 2 pi. I can factor out a tangent, which leaves me with tangent plus 1 in parentheses equals 0. Then I can use the zero product property to set each of these equal to 0. I'm looking for where tangent equals 0. This one is going to refer to this graph. I don't think I have this on here. Tangent is y over x. So I'm looking for where my y value is 0, because that will give me a 0 value. Tangent equals 0, y equals 0 at pi halves and 3 pi halves. And then I don't have to do the plus 2 or plus pi n here because it's giving me a restricted interval. Then over here, I want to subtract 1 on both sides, which gives me tangent x equals -1. This one is off of this chart. Remember, both this chart and this chart you will have to have memorized for the test. But this one, tangent's right there at pi fourths. If I think about where tangent is positive, it is positive in these two quadrants. So I want it negative in this quadrant and this quadrant. So I want pi fourths in those quadrants. If it's in the original quadrant, it's just my angle. If it is in this quadrant right here, I do pi minus the angle. If it's in this quadrant, I do pi plus the angle. And if it's over here, I do 2 pi minus the angle. So I want it in the second and fourth, and it's pi fourths. Pi minus pi fourths will give me 3 pi fourths. And over here in this quadrant, 2 pi minus pi fourths gives me 7 pi fourths. So all 4 of these are my answer. Okay. Number 4, I want to solve, but notice I have 2 different trig functions. What I need to do is I need to turn the secant into tangent. I can use my identity right here. Secant squared equals 1 plus tangent squared. Then I just want to go ahead and move everything over to one side and then combine like terms. So I'm going to start off by subtracting 4 on both sides. This is going to give me tangent squared x minus 2 tangent x minus 3 equals 0. So I'm looking for what multiplies to -3 and adds to -2. That is going to be -3, +1, Then I want to solve these and see what I get for my answers. I get tangent x minus 3 equals 0. Tangent x plus 1 equals 0. This one I want to add 3 to both sides. This one I want to subtract 1. Okay, this one has an answer, but we're not going to have tangent on the test. It's not a nice value, so I can't say it in terms of radians. But over here, I know what tangent of x equals. This is, the first quadrant it appears in is 3 pi fourths. I don't have an interval here. Tangent repeats every pi n. And I need to say where n is any integer. If I don't say that, I won't get full points. So, for this review, this is the answer I'm looking for. Okay. Number 5 wants me to solve this equation. What I want to focus on is the sine part, and that I'm looking for radical 2 over 2. That is 45 degrees, and sine is positive in those first two quadrants. So I am going to have pi fourths. And then in the second quadrant, it's pi minus pi fourths, which gives me 3 pi fourths. Again, no interval, so it's plus 2 pi n. And then I take the x from inside my equation, so I have 2x, and I want to divide these all by 2. So for my first equation, that's going to give me x equals pi eighths plus pi n. On the bottom equation, again, I divide everything by 2. This gives me 3 pi eighths plus pi n. And I want to say, I don't know why I wrote that all in red. Again, since I had no interval, I need to clarify that n is any integer. And this is so I don't mistake it for thinking it's like a fraction I can plug in. So this is my answer here. Okay, number 6 wants me to find the exact value of tangent A alpha plus beta, given that tangent of alpha is in between pi and 3 pi halves. So I want to draw this out. Pi, remember it goes 0, pi halves, pi, 3 pi halves. Pi and 3 pi halves is right here. This is my alpha triangle. Tangent is 20 over 21. So opposite over adjacent. Because I'm in the third quadrant, both of these side lengths are going to be negative. My missing side length is going to be 20 squared plus 21 squared equals c squared, because I have my two side lengths, or my two leg lengths. So 20 squared plus 21 squared gives me 841. Then I want to find the square root of 841, which is 29. So that's my hypotenuse. Then I want to go do the same thing for my beta triangle. This one is telling me it's in between pi halves and pi. So that's here. This is cosine. So this is adjacent over opposite. My missing side length here is a positive 12 because it's going up. Then I just want to plug into the tangent formula for sum and difference. I had, was it plus? I was adding my alpha and my beta, so this is the formula I'm using right here. The tangent alpha plus tangent beta over 1 minus tangent alpha beta times, I can't talk. Tangent alpha plus tangent beta over 1 minus tangent alpha times tangent beta. And then I'm going to plug in my values. So this one I actually didn't need to draw my triangle. Oh no, I did. This one wasn't given me tangent. You need to use the information from each of these triangles. So, tangent alpha is this triangle. That was 20 over 21. Tangent beta is this triangle. So that is opposite over adjacent, 12 over negative 5, over 1 times 20 over 21 times 12 over negative 5. Then I just want to go ahead and simplify things. On my numerator, this one's going to need to multiply by 5 over 5. And this one's going to need to multiply by 21 over 21. For my first fraction, it gives me 100 over... I don't think I did that right. I did not. It gives us 105. Then my second fraction, I'm not even going to risk it. I know it's a minus because of that subtract down there. 12 times 21 gives me 252. And then I know that should be 105 on my denominator. On the bottom here, I'm multiplying straight across. I have a negative from the formula, a negative from this 5, so it's going to make that positive. 20 times 12 is 240. 21 times 5 is 105. On my numerator, I can combine like terms. 100 minus 252 is negative 152 over 105. On the denominator, I make this 105 over 105. So 105 plus 240 is 345 over 105. I have a fraction over a fraction. So I'm going to multiply by the reciprocal of my denominator. Those hundreds and fives will cancel out. So I have negative 152 over 345. I just want to check to see if that can simplify on my calculator. So I type in that fraction, then I go math, fraction, it gave me back the same fraction, so this does not simplify. Okay. Number 7, on the test this will tell you what to use. This one is using sum and difference. So I am going to do, I don't really care for this one. I am going to do 45 minus 30. You could have also done 60 minus 45. So this is my alpha, this is my beta. Order matters. I'm doing difference of cosine, so I'm using this formula right here. So it's going to be cosine alpha, which is the 45, times cosine beta, which is the 30, plus sine alpha, which is the 45, sine beta, which is the 30. And then I just want to know these values. This is from that chart I showed you earlier that you need to have memorized. Remember, the way to create this if you don't have it memorized is it goes 1, 2, 3. Take the square root of all of those. Square root of 1 is 1, so that one stays alone. Divide everything by 2. Cosine goes 3, 2, 1. Same deal, take the square root of all of those. Tangent divides sine by cosine. And then that's how I get those values. It goes pi 6, pi 4ths, pi 3rds. I go from largest number to smallest on my denominator. If I'm in degrees, it goes 30, 45, 60. So then cosine of 45 is the square root of 2 over 2. Cosine of 30 is square root of 3 over 2, plus sine of 45 is the square root of 2 over 2. Sine of 30 is 1/2. This first fraction right here, I multiply together. Square root of 2 times the square root of 3 is square root of 6. The denominators multiply together to give me 4. Over here, square root of 2 times 1 gives me square root of 2. Again, my denominator is 4. I just want to go ahead and make this one giant fraction. So this is my final answer. If I use the double angle formula on this problem, I would lose points on this question because I did not use the method it wanted me to use, which is sum and difference, which will be typed on the test, not typed on the review. So Number 8 tells me if cosine is 12 over 13 and lies in quadrant 4, I need to find sine of 2 theta. So quadrant 4 is right here. 12 over 13, that makes this a negative 5 because that's going down. Sine of 2 theta is using a double angle formula. So this is this one right here. I want to find 2 sine cosine. So I'm going to use this triangle to get those values. Sine is opposite over hypotenuse, so negative 5 over 13. Cosine is adjacent over hypotenuse, and it was also given to me in this problem. It's 12 over 13. I want to multiply all of these straight across. Remember, this 2 is over a secret 1. So 2 times negative 5 is negative 10, times 12 is negative 120. 1 times 13 times 13 is 169. So then I just want to check to see if this simplifies. It does not. So that is my final answer here. Okay. Number 9 wants me to use the half angle formula to find the exact value of cosine of 5 pi 12ths. I would need to figure out double the angle, so I'm going to multiply this by 2, which will give me 5 pi 6. Then I want to plug into the half angle formula. Again, you have to use the right formula here. I need to know if it's positive or negative. So 5 pi 12ths is 1.31. So I know this is 3.14. This one is 6.28. Oops, that's not on the screen. Let me figure this out really quick. 1.57. And then, just in case you wanted it, this last one down here is 4.71. So 5 pi 12ths is 1.3. That puts me in this quadrant. So it's going to be positive because 5 pi 12ths is a positive angle. Then the formula is here 1 plus cosine alpha, which is the doubled angle, so 5 pi 6, over 2. Let me label that this is 5 pi 12ths. Okay. Then I want to keep going. I'm not going to write that plus anymore now that I know it needs to be positive. I want to find 5 pi 6, but 5 pi 6 is right here. That means I need to use a reference angle. For reference angles, this is always the angle I use. Reference angles are finding the distance from 180, distance from the x-axis, which is either 180 or 360. So in the second quadrant, it's going to be pi minus my angle. In the third quadrant, it's the angle minus pi. In the fourth quadrant, it's 2 pi minus my angle. If I'm in degrees, it's 180 minus my angle. My angle minus 180, or 360 minus my angle. Then 5 pi 6 is pi minus 5 pi 6, which gives me pi 6. Cosine in the second quadrant is negative, so I'm going to write this with a negative right there. It is still over that 2. It's going to be 1 minus, because the plus times the negative. Cosine of pi 6 is square root of 3 over 2. This is still all over 2. I want to make my numerator have the same fraction. So I'm going to multiply by 2 over 2, which gets me 2 over 2 minus square root of 3 over 2, all over 2. I want to make my numerator one giant fraction. So it's going to be 2 minus the square root of 3 over 2 over 2. I want to get rid of the fraction in a fraction. So my first fraction stays the same, and then I multiply by the reciprocal. This 2 is over a secret 1, so my reciprocal is 1 over 2. This is going to give me square root of 2 minus the square root of 3 over 4. I can split the radical up between the numerator and the denominator. And then I can't take the radical of my numerator because of the radical inside. That is going to stay alone. But on my denominator, the square root of 4 is 2. So that is my final answer here.